Okay. So just total four things are given in this. AB and CD are parallel, and AB is perpendicular to AD, and AB is 2CD, and area is 18. What is this radius? That is the question. Okay. This is R, this is R, this is R, this is R from the figure. I want to take this small length as X. Because this is R plus X, this total will be double of that, 2 times R plus X. And if I remove R, only this length will be R plus 2X. This is R plus X, so this total is that. Now, how to find a relation between R and X, and then we have to use even this area also. First of all, you have to find relation between X and R. This length into this length, the product should be R square. Or this length into this length, the product should be R square. In circle chapter alone, we can prove that. Okay. In ellipse also we discussed this. If an ellipse has two parallel tangents like this, or it has two parallel tangents like this. If we take any other tangent, this length and this length, the product is constant. Even here, if we take any other tangent, this length and this height, the product is constant. Same thing is true even for ellipse, the circle. For the circle, these are the two tangents. This length and this length is same as this length and this length. The product is constant. In ellipse, I don't think this product is constant. This and this, or this and this, but this and this are constant. Whereas in circle, this and this are equal, so it becomes easier. So how to prove that this one and this one product is R square? Okay. One method is you join these two. You join these two. Because these two are congruent, this angle are equal. I'll call alpha alpha. Because these two are also congruent triangles, I can say these two angles are beta beta there. But total 2 alpha plus 2 beta is 180 degrees. So alpha plus beta is 90 degrees. So only this OBC is a right angle triangle. In any right angle triangle, this length and this length, the product will be square of this, the height whole square. So if I call this as some P, PC into PB is equal to OP square, which is R square. This is PC X. PB is R plus 2X, which is equal to R square. From this, I can find relation between R and X. R square minus Rx minus 2X square equal to 0. R square minus Rx. This I can write minus 2Rx plus Rx. So I'll getting R minus 2X into R plus X equal to 0. So R equal to 2X or minus X, this can't be. So R equal to 2X. If R equal to 2X, this will be 4X. This will be X. Then this will be 4X square. Yeah, that's good. Or you can say X is equal to R by 2. Either way is fine. This is method 1 to prove relation between R and X. Area will use it later. Method 2, basically why this into this should be R square. Okay, I want to prove another way. I'll take this as R and this length as Y. This is R and this length is X. I will draw one vertical line here. Okay. If I take only this right angle triangle separately, what is this height? They made this height, which is 2R. What is this length? This is y and this is x. If I remove, this will be y minus x. What is this is, this is x and this is y. So it will be x plus y. Just use Pythagoras theorem. 2r whole square plus y minus x whole square is equal to x plus y whole square. If you send this x minus y whole square that side, you will get 4r square equal to 4xy, which means xy equal to r. Okay, same. That y only is r plus 2x here. So you can substitute. Whatever it is, we got a relation between this. Now, what about area of a trapezium? Half h into a plus b. AB equal to 2CD. AB is parallel to CD and AB is perpendicular to, right. Area 18. Area half into base is 2r. Half h. A is r plus x. This will be 2 times r plus x is equal to 18. 2 will cancel. Here we are getting 2r into r plus x whole square equal to 18. In the place of x, I can write r by 2. So basically, I got area in terms of radius, so I'm able to find the radius. 3r, so it will be, cube is coming for area. This is plus 1. Half h into a plus b. This will be 2 will cancel. R into 3 times r plus x is 8. R into r plus x is r by 2 is 6. R into 3r by 2 is 6. So r is equal. R square is 4. So r equal to 2. Okay. So mainly are able to realize why this length into this length product should be r square. One is by right angle triangle property. If that is also not clear, one more step I can write, because this also will be alpha, because alpha plus beta is 90. In this figure, tan alpha will be Cp by OP. In this tan alpha will be OP by PB. So when you go to cross multiplication, you'll get PB into PC equal to OP square. That is this. And the same step we got x into y is r square, where this is x and this is y. Is everybody clear about 21?
Yes, sir.
Okay. So please try to understand, and if you have any doubt, please ask.
So how did you find that method to y equal to x plus 2y? How you know that one?
No, y equal to x plus
For
y
method
equal to x plus 2. Where is that? How r equal to 2x? How will you get from this? You're asking.
yes, sir.
Okay, that is already mentioned in the question that this length is double of this. So you'll replace y with r plus 2x now. X into in the place of y, write r plus 2x. Solve that quadratic equation, you'll get r equal to 2x.
Nice. Understood. Thank you, sir.
Here also I should have kept y first and then later on that. Okay. This is x into y equal to r square. This is y. Okay, initially I thought this KVPY paper discussion will be, just 1 or 2 days, or in 1 or 2 hours I can complete, but it's taking more time. So then I thought every day few questions we can discuss. Okay. So today the 2019 paper, whatever questions are left 17 to 1 backwards, I will discuss. Every day I'll discuss only half an hour, 3:30 to 4, whatever is possible. Or if anything is left, we'll continue tomorrow. If that is 2019 is over backwards, then we'll go for 2018, but 2018 we'll discuss in the proper order only, from 1 to end. Just a minute. Okay, those completed 21, they can do 23. Please put down your videos, all of you. Okay, I'm going to erase 21. Does anybody need more time or any doubt?
No.
No, okay. Okay. 23. I always like this question, but I always want this question to be in circles, sorry, first year trigonometry. Okay, let me explain the question. We have concentric circles, all with center 0, 0. This radius 1, this radius 2, this radius 3, this radius 4, so on. You start at 1, 0. On this travel 1 unit. Go radially to the next circle. Because that radius is true, travel 2 units. Go radially to the next circle. Travel 3 units. Go radially to the next circle. Travel 4 units. So on kth circle, you have to travel k units. So start from 1, 0, travel 1 units, go radially to the next circle, travel k units, and then go radially to the next circle, travel another k units, so on. So here you crossed negative x-axis. Later on, we will go further like this and further like this Okay. When is the first time you are going to cross positive x-axis once again? That is the question. Anybody want to answer this?
Sir, you
Yes, yes.
say when means what we should do means after some
When on which numbered circle, what should be the radius of that circle on which it is there while crossing positive x-axis?
Sir, it is we are crossing radians, sir. 1 radian, we are moving one on like that, sir. How many
Yeah.
radians first time will cross, sir?
Yeah, correct. Here the radius is how much length you are traveling is changing, but how much angle you are rotating every time is fixed. On a circle of radius r, if you travel an arc length of r, how much angle it subtends in that sector is 1 radian. That's the definition of 1 radian. So you rotated 1 radian here, 1 radian here, 1 radian here, 1 radian here. So when you want to come to positive x-axis after starting from here, you have to do one complete rotation. You have to turn 2 pi radians. Okay, so 2 pi radians means 6.28 radians. So 6 radians means you already covered 6 circles, and now you are traveling on the 7th circle. While you are traveling on the 7th circle, you are crossing positive x-axis. Okay, so you are on a circle whose radius is 7. So 7 is the answer. Okay, so 5 is like
Yes.
this, 6 is like this, and radial outward, and you are right now traveling on 7. Okay, it is given here, nothing wrong because circle is there. But I always like this question because it demands you to remember the definition of radian and use it. Otherwise, over time we may forget what is the radian definition. Okay, that's all. That's the question. Okay, so if you read the question, for each natural number k, let Ck denote the circle with radius k centimeters and center at the origin. On the circle Ck, a particle moves k centimeters in the counterclockwise direction. After completing motion on Ck, the particle moves to Ck plus 1 in the radial direction. The motion of the particle continues in this manner, and the particle starts at 1, 0. If the particle crosses the positive direction x-axis for the first time on the circle Cn, then what is n value? That is the question. Every time it is turning 1 radian, so 6.28 radians it has to cover for one complete circle. Then on 6 circles, it should have crossed and then traveling on the 7th circle. Okay, anybody else still doubt about 23?
No, sir.
No. Okay. 25. What is this? 2. Read 25 and try. So where these two lines are intersecting, if I add 10x 5 comma 0 are intersecting. And x is 5, 25. minus 5 by 4. 5 comma minus 5 by 4. Oh, it is touching. Okay, this is a very silly question where this lines equation and all doesn't matter. Okay, because they asked only radius. So it is fairly simple. Let me draw another figure and explain. 25th question, if they would asked the center, it's some at least some calculation. Radius is very simple. What is that? I have two lines. A circle is touching both of them. The center in first quadrant or not, it is not going to play any role. This radius is 3, this radius is 3. You take same center but increase the radius little bit. I'll get one circle. That circle should make an intercept of 8 units on each of these lines. Okay, so this is 4 and this is 4. Now, what is the radius of this new circle? That is very simple. This is 3, this is 4. So, what is this length and what is this length? What is the radius will be?
5.
5. That's all. The lines equations, their slopes, their point of intersection doesn't play any role. When it plays a role is if they wanted this center. Then you have to worry. This is also 5, this is also 5, something. Okay, that's it. So we are done with the circles where all the theory is taught. We're done on simple formulas, past year MCET questions, and then advanced material, all the odd numbers are discussed. So I think we should cover most of the models. So now I'll discuss even number doubts. Up to somewhere, I think I discussed even number doubts, right?
More than one, sorry. Single option questions all you discussed.
Okay, more than one I have to discuss. Okay. By tomorrow, all of you can complete circles, sir. Advanced material also fully.
Yes, sir.
Yes, sir.
All right. So tomorrow, if we discuss doubts, day after tomorrow, I can start parabola.
Sir, once can you explain again 25th question, sir?
Oh, 25th is very simple. There are two lines. What are their slopes? What are the angle between them is not at all important. Okay. There is a circle touching both of them. The diameter is 6 means radius is 3. Concentric to this, there is one more circle. Obviously, that will not touch these two lines, but it will intersect these two lines, such as that this intercept is 8 units, this intercept is 8. So this is 4, this is 4, this is 4. Now, what is the radius of this new circle? This is 3, this is 4. So what is this radius?
5, sir.
That's all. That is the question. If you just read and understand, you can easily tell radius is 5.
Understood. Thank you, sir.
Yeah. All right. Now let us discuss your doubts. Single answer fully discussed it seems. So more than one answer we are going to discuss. Okay, you can see on the screen more than one answer. Second question. Anybody any doubt? You can take your homework books and see where you are done. If you left some gap or doubt or did not get the answer. Okay, so more than one answer. Second question. Any doubt?
No, sir.
Okay. Fourth question. Any doubt?
No, sir.
Okay. 6.
So fourth one.
Fourth one. Okay. Tangents are drawn from a point P on the circle to another circle. The tangent meets original circle at Q and R, and QR is tangent to C2. Okay. Look at the figure, right? I have two concentric circles. Take any point on the bigger circle, draw two tangents to the inner circle and extend them. They'll meet the original circle at 2 points. When you join them, they're touching this in circle. Okay. This is C1 and this is T2. From a point on C1, tangents are drawn to C2 and extended. They'll meet the original C1 at Q and R, and it so happened that QR. Okay. Then actually it must be equilateral triangle. All right. Why it should be equilateral triangle? If all are at the same distance, they're touching the circle, means they're at same distance. If they're at same distance from the center, their lengths also should be equal. In a big circle, if three chords have same length, that is, if three chords are at same distance from the center, the lengths of the chords are also equal. If all these lengths are equal, then it must be equilateral triangle. Then once it is equilateral triangle, if you know the length, you can do it. What is A and what is B? B is this length. Okay. A is this length. So obviously A equal to 2B, one relation, because that is this is also A, this is also A, this is B. A equal to 2B. Okay. Next, if you know the side length, you can find, or if you know circumradius, you can use what is the 2r square sin A sin B sin C. If you take this full thing, delta is equal to 2r square sin A sin B sin C. Or you can simply find from right angle triangle this length, double of this, and then do it also, find it will come. Radius, the big radius is A, circumradius. Sin 60 is root 3 by 2 into root 3 by 2 into root 3 by 2. 2 will cancel, 3 root 3 by 4 A square. If you substitute A as 2B, you will get one more answer. If you substitute only one A as 2B, you will get another answer. You can write A square, you can write 2B whole square, or you can write one A is as it is, another A 2B. So by replacing A square with this or this, you'll get two more options. Mainly it is important to recognize that these tangents are, when they're extended, they meet the original circle at Q and R such a way that the QR is tangent to the same inner circle. Because from the center, all these are tangents to the smaller circle, their perpendicular distance are B. From a bigger circle center, if the perpendicular distance are equal, all of them should have same length. So this must be equilateral triangle with in radius B and x radius, circumradius as A. Then you can find area in terms of A or B or both. Is it all right? Fourth one?
Yes, sir.
Okay. Any doubt about sixth question? No doubt. Eighth question, anybody doubt? Tenth question.
Sir, option B.
10th question, option B.
Yes, sir.
Okay, equation circle passing motion tangential to the lines. Okay, these are two perpendicular lines, so there will be definitely two answers. Even if they are not perpendicular, also there will be always two answers. Okay, now where these will intersect if this for the sake of 2x equal to 2, x is 2 and y is 0. Okay, they're intersecting here. One is this, and minus 1 comma 1. Okay, one circle like this and one circle like this. This point is minus 1 comma 1. Okay. So whenever a circle is touching two given lines, okay, the center of that circle, that's why I have two lines. Lot of circles are touching the two given circles. But join all of them centers, it will be angular bisector. So because from that this perpendicular are equal, so these angles are equal, either this or this. Okay, so when you find angular bisectors of the given two lines, you will get one is x equal to 2, another is y equal to 0, which is x-axis itself. Okay. Now, how to find the center and radius? You take this as k comma 0, the center. You can find the radius. Okay. And passing through minus 1 comma 1 is also radius. Okay. You can find this distance and this distance equated to get k value. Then the center is k comma 0. It should be on x-axis. So what is the perpendicular distance to any one of the lines? Mod k minus 2 by root 2. What is the distance to this point? K plus 1 whole square plus 1 whole square. That is 1. You solve this, that is also square here. So there is a root there. K minus 2 whole square is equal to 2 into k plus 1 whole square plus 1. You expand this, you'll get a quadratic equation, get two values of k. And once you get two values of k, the corresponding radius also you'll get, then you can find. So obviously there will be two answers. Is it okay, 10th one? Sanjana?
Sir, I solved it by taking the equations, sir.
You want to take general circle, GFC.
Yes, sir.
Then what about mod? When you take from the center perpendicular equal to radius, you have to take mod, right?
Yes, sir, I took
So,
mod.
so
We
that
got
means plus or minus 2 cases will come for one line, plus or
Yes.
minus 2 cases will come another line. Total 4 cases will come for you. Yes or not?
Yes, sir.
Okay. In that two cases, there will not be answers. Then two cases, there will be answers. Is it okay?
I'll try it again, sir.
Okay. So the GFC method is good, but not that all questions will do like that. If you visualize and it is somewhat easier. Okay. Here you can know where is the center. Center should lie on angular bisector. And which angular bisector to take? That angular bisector which is passing the region in which minus 1 comma 1 is there. Because if minus 1 comma 1 is not even there in this, how can a circle come in that and pass through this? Not possible. So when you take a point on that, you'll get two negative cases. There's two cases without any. Is it all right? 10th one. Anybody else if they have doubt? Okay, up to 10 even numbers in more than one answer. Any other doubt anybody has? Okay, 12. Anybody any doubt? 12 yes, sir? No.
No, sir. Up
No.
to 10 more.
Okay. 14. $16.
Yes, sir.
Basically, they want center and radius of circle which touches both the axis but not the line. If something touches both the axis and touches the line, you find, except that other things are okay. 16. Okay. X-intercept for this line is 3 and y-intercept is -4. Yes. So fourth quadrant like this. X-intercept 3 and y is -4. So there will be one circle here, some circle like this, some circle in first quadrant, some circle in fourth quadrant where when you extend it will touch. Like this. Okay. Basically for a triangle, there will be one inner circle and 3 x circles. So total there should be 4 answers. You can use properties of triangles more equal to delta. Yes, please.
But they asked the circle which do not touch the line.
Yeah, with touching the line, we'll find. Okay. We'll find all these 4 answers except that anything else is answer. There are infinite answers, right? You can even verify from the options also because all the options are touching coordinate axis because their mod of x coordinate of the center, mod of y coordinate of the center is equal to the radius. So that means they're touching x and y axis, no doubt. Now from each center, we find perpendicular distance to that line, which is equal to radius touching. If not, it is intersecting or completely separate. Okay, so you can verify from the options very easily. So I can say that method 1, verify from options. Method 2, how to find the positive answers so that we can know which are not correct. What is this? This point is 3, 0. This point is 0, -4. This line equation is 4x minus 3y minus 12 equal to 0. If I want to find this one and this one, okay, simultaneously I can find. I will take both this and this, first quadrant and third quadrant as center r comma r and the radius mod r. When r is positive, radius cannot be negative, but my r is not radius, mod r is radius. When r is positive, I'll get first quadrant. When r is negative, I'll get third quadrant, both covered. But you should touch that line. So from center perpendicular equal to radius. So mod 4r minus 3r minus 12 by 5 is equal to radius. Mod r minus 12 is equal to 5r. R minus 12 equal to plus r minus 5r. When you take plus 5r, you'll get r equal to minus 3. When you take minus 5r, you'll get r equal to 2. So when you take first quadrant, center 2, 2, radius 2. In this. When you take minus 3, center minus 3, 3, but radius plus 3. Center radius. If you want to cover second, you don't have any answer in second quadrant, but you want to cover second and fourth quadrant. You can take center as r comma minus r and the radius mod r. If r is positive, we'll be covering fourth quadrant, r is negative, we'll be covering second quadrant. From here to that line, what is the distance? 4r plus 3r minus 12 by 5 is equal to mod r. That is 7r minus 12 is equal to 5 mod r. So when you open it, we'll get 7r minus 12 equal to plus r minus 5r. When you take plus, you'll get r equal to 6. When you take minus, you'll get r equal to 1. Okay, so one of them is 6 comma minus 6 and radius 6. Another is 1 comma minus 1 and radius 1. Okay, these 4 are correct. Anything else you can see which will not be correct. Total 4. 1, 2, 3, 4. We can also use small r equal to delta by s. We know this length, this length, this length. Give some names ABC. Find small a, small b, small c, and s, and then delta, and use in radius, this x radius, that x radius, that x radius. You can find all 4 also. That is one more method. Is it okay? 16? More than one answer?
Yes, sir.
Okay. Any doubt?
No, sir.
No. 20, anybody any doubt? No. 22. 24. That's it. Have all of you tried passages?
No, sir.
Yes.
Okay, some people are saying yes, some people are saying no. We have some time. So we can start parabola then. By tomorrow, everybody can complete circles fully.
Yes, sir.
Okay, then I'll do one thing. That KVPV class I'll start at 3:25. I'll start and start class at 3:30. Right now, I want to